Kia ora koutou. This is a nice complex numbers question from back in June 2011, and it's Pure 3, paper 31. Should have said that up there, and it's question 8. If you do this first bit well, the next two bits are not too bad. As usual, the key here is to do a lovely big diagram. Okay, so we'll start by finding the modulus of this complex number u, and then we'll show that the argument of it is negative pi on 2. Now, just looking already at a diagram, if the argument of something is negative pi on 2, what we're looking at is for u to end up being on the negative part of the imaginary axis, and that's the goal that we want to get to. So let's start off with looking at what u is. And so the most obvious way to do this one, especially when I find my piece of paper with u on, is to multiply top and bottom of the fraction by the conjugate, right? So 1 minus 2i, 1 minus 2i, carefully working through that because it's a show that question. I get 1 plus 4, and up here I get 6 minus 3i minus 12i plus 6i squared, which equals 6 minus 15i over 5, and that gives me a very nice negative 3i. Now let's draw a bad diagram here and show negative 3i, and show that arg of u is equal to negative pi on 2. That's probably enough, but maybe better to say that it's, since negative 3i is on the negative part, or the negative imaginary axis. So then the next couple of bits of the question obviously use that. So if you've stuffed that up, you're going to be in trouble. We have to now find a locus. So we want the locus satisfying this, that the angle between z and u is 45 degrees. So let's go over, first of all, really slowly. What's the arg? If the arg of z is pi on 4, what am I drawing? Well, I'm drawing a half line from the origin like this. So the angle here is pi on 4. If instead I'm drawing the arg of z minus negative 3i is pi on 4, then what I'm drawing is a half line that starts, and I'm going to do this more neatly in a minute, starts at negative 3i, and the half line there goes like that. So that means that the equation of that curve is going to be negative 3 plus x, right? Because I'm still working with a 45-degree line. So the equation up here is y equals x. The equation down here is just y equals x shifted down by 3. Let's look at why this works. So if we've here, what I've got is arg of z plus 3i is equal to pi on 4, right? So this is arg of z minus u. If I take every suggested point on that locus and I add 3i onto it, then what I'm doing is I'm transforming that line. It's going to move up to here, and we get back to this one up here that we started with. All right, so that's what's going on with that transformation. So by this stage in the year, being able to plot the locus that I just did here should feel like second nature, right? That part of the question should not feel bad at all. The next part is where we have to do just a little bit of thinking. We're looking for the point on that locus where the modulus is the lowest possible. So I'm going to draw that reasonably accurately and reasonably bigly. I'm not sure if bigly is a word. 1, 2, 3. I'm going to put my point on down here. And now I'm going to draw my 45-degree line up here. The reason I'm doing it like this is I want you to get where the smallest modulus point will be on that locus. So that locus needs an open circle there. And you can see that as I move that ruler, the distance between here and the points on the locus is getting smaller and smaller. And it's at its smallest value. Just put it in another color. Sorry if this is too slow for some of you. If it is, just hang up and watch a different video. Right, so this point here is the one that I want. And it's where we've got the orange line being perpendicular to the purple line. So the orange line has equation y equals negative x, right? That's because this line has got equation x plus 3. And we know that perpendicular gradients multiply to negative 1, blah, 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 right? But by this stage in your maths careers, you should intuitively be able to see that this will have a negative 1 gradient. right? So these meet at 45 degrees. What are the coordinates of that point? Because what I've got to find is the length of that line there. So I can do this using coordinate geometry, or I can do it by looking, because I can see here that I've got a triangle here with that length being 3. We want to know that one, and we want to know that one. But just by inspection, this angle here is 45 degrees, right? And this one here is 45 degrees. So the fastest way to do this is using similar triangles. This is my 1, 1, root 2 triangle, and the one that we want has got my long side being 3. What did I do to the root 2 to get it to be 3? Well, I times it by 3 and I divided out the root 2. So that means that these two sides must each be 3 over root 2. But that is what I'm after, right? I want the length of that line. So if we've done a good graph, we can say that the modulus of z is equal to 3 over root 2. And we can rationalize the third and get this. So both of those are fine. Now, if we didn't spot the similar triangles thing, we can do it using coordinate geometry as follows. We can get the coordinates of the point here by saying that we've got the intersection of the two lines. So we've got negative x is equal to x. Is that right? Negative x is equal to x minus 3. That gives me 3 is equal to 2x. So x is equal to 3 over 2. And we know that y must equal negative 3 over 2. So we can find the coordinates of the point, and then we can figure out the distance from 0, from the origin, to that using Pythagoras. And it will be 3 over 2 squared plus negative 3 over 2 squared, which gives me, this is very slow, but here we've got 4, and up here we've got 9 plus 9. So that's 18 over 4, and this is 9 over 2, which gives me 3 over root 2, as before. Okay, let's look now at the last part, which is in some ways faster than the part we've just done, if we spot the locus that we're getting. For complex numbers satisfying this condition, find the greatest possible value of the modulus of z. In other words, find me the set of points satisfying this, and then find the one that is furthest from the origin and find its modulus. So u is equal to negative 3i. 1 plus I times u is equal to 1 plus I times negative 3i, which is negative 3i minus 3i squared, or 3 minus 3i. What we're after is this, z minus 3 minus 3i. We want the set of all points such that the distance from that point to this is equal to 1. And that's giving me the modulus, the locus of a circle. So let's remove the stuff off here. Get rid of all of this. We're going to plot a circle with a radius of 1 that's centered at 3 minus 3i. So here's 3 minus 3i. Let's just count out 1, 2, 3. You're going to do this with a ruler, hopefully. So 3 minus 3i. And the circle is going to be just here. And then we've got to find the point with the biggest modulus. So it's going to go to here, to here, to here, and to here. Let's draw the circle in. So where is the distance from the origin going to be the greatest? Take your ruler and look at what's going on. Well, it's going to be when I'm on that 45-degree line, right? Because when I'm over here, so it's somewhere on this side of the circle around here, but it's going to be when that's at a 45-degree angle. And we need to find what that point is, what the modulus of that point is. So we don't need to find the coordinates of that point. This point here is the point 3 minus 3i. And this point out here is somewhere, but we know that the radius is equal to 1. So all I've got to do is find the distance from the origin to the center of the circle, and then add on 1. And then add on that 1. and that's equal to the square root of 3 squared plus negative 3 squared, which is the square root of 18, which is equal to 3 root 2. So the least value of that locus is 3 root 2 plus 1. Okay, there are other ways to do that, but I think that's probably the fastest. Thanks for watching. I'm going to video a few other questions in this paper, but please keep on sending your questions in. And remember that vectors are still in, but the vectors questions are more like the ones in the old AS papers, not the ones that have got planes in them. So any question about a plane is not coverable now, but pretty much anything else still is.